Good day everyone! So today we'll be learning about the thermodynamic loop. Alam natin in a cyclic process, where the initial state is equal to the final state, the change in the value of a state function, theta, is 0. Or written mathematically, the summation of the delta theta in a loop is equal to 0. So we usually use the thermodynamic loop to find the enthalpy change or the entropy change or the free energy change of a reaction done at an elevated temperature. So take for example this hypothetical equation where we're changing A plus B to C. This is done at 298 Kelvin, and at 298 Kelvin we can get the enthalpy change of the reaction from the formation enthalpy of A, B, and C. But what if we wanted to find the the enthalpy change of this reaction at an elevated temperature T2? Yung reaction at that T2 or that temperature is this one, NAA plus NBB to NCC. So same lang dun sa 298 Kelvin. But we'll see that we'll have a different delta H of reaction since iba na rin yung temperature. So we know from going from temperature of 298 Kelvin to temperature of T2, we need to apply heat to each of these components to put them in a higher temperature T2. So in this case, we apply delta HA, amount of heat, to A, delta HB, amount of heat, to B, and delta HC, amount of heat, to C. So for the thermodynamic loop to happen, first we need to know what are the different states of the system. So in this system, or in this cycle, there are actually 4 different states as boxed in here. So meron tayong state na puro reactants lang at this one. Meron tayong states na puro reactants lang at 298 Kelvin. Meron states tayo na products lang siya at 298 Kelvin. States na puro reactant lang at an elevated temperature T2. And meron tayong state na products lang at an elevated temperature T2. So makita natin, pwede natin gawin yan na parang cyclic process by putting this arrow here. So ito na yung thermodynamic loop natin. It is as if we're going back to the same original state when we go around one cycle of this loop. So yan yung concept ng thermodynamic loop mo. In the thermodynamic loop, we have meron tayong rules na sinusunod. So sa thermodynamic loop, if your system or if the direction of your if the direction of your loop is the same as the direction of your reaction, we take that as positive. So ito positive, same direction with the loop. This one is positive as well. If opposite na ng direction, yung reaction with the loop, so ito negative, ito negative, and ito rin negative, yung kukunin nating values nung ating delta H here. Then, i-equate natin lahat ng delta H natin to 0. Since loop nga siya, sinum natin lahat ng delta H. So, basically, we're just accounting for a cyclical change or cyclical process. And we'll get the following. Delta H reaction at 298 Kelvin plus the NC delta HC. So, since positive nga sila, positive and positive. Then, yung delta H reaction T, delta HB, and delta HA are now opposite direction of our loop. So, negative na sila. Negative, negative, negative. And equating all of these, you will get 0. We're usually looking for the delta H of the reaction at an elevated temperature. So, we can isolate that on the other side. And we'll get this one. So, this already is what, ito na yung pinaka-thermodynamic loop natin. From the thermodynamic loop, we can get this equation. And mula dito, kaya na nating masolve yung delta H reaction at T. Since we can easily get delta H reaction at 298 Kelvin, NC delta H, NB delta HB, and NA delta HA. Since ito lang naman yung reaction, so reaction enthalpy at 298 Kelvin, and the amount of heat needed to increase the temperatures of A, B, and C to an elevated temperature T, as shown here. Now recall, that to increase the temperature of a substance, we have to use the heat capacity. Delta Hx will then be equal to this integral of the constant pressure heat capacity with respect to temperature. So for each of the components, C, B, C, B, and A, we have this. We multiply this by the number of moles, NC, NB, and NA. Depende na lang kung ilang moles meron tayo sa reaction. Then, we can actually put them together. NCP, NC, NB, and A, yung CP, ni C, B, and A, to have this delta CP. So basically, pinag-combine lang natin to. So this is only valid if the components have no phase transformation going from 298 Kelvin to an elevated temperature T. But if meron na tayong phase changes, we now have to take into account our latent heats associated with transformation, and we'll get this one. So this is para maging final equation natin for the thermodynamic loop. So we can either use this equation or you can use this one. So personally, I use this one rather than the other one kasi dito at least kaya natin ma-account or mas madali, hindi natin makakalimutan i-count yung ating latent heats. To show how we can apply the thermodynamic loop, let's try an example. So let's calculate the standard heat of formation of lead oxide from lead solid and oxygen gas at 227 degrees Celsius from the following data. The chemical reaction is just the combination of lead solid and oxygen gas to form your lead oxide solid. So to solve this problem, we first set up our thermodynamic loop. So to set up the thermodynamic loop, we write our equation first. So we have PB plus O2 solid gas 1/2 to form PBO. This is temperature of 298 Kelvin. We want to look at PB solid plus 1/2 O2 gas PBO at a temperature of 500 Kelvin. So this is 273 degrees Celsius. We are increasing the temperature for each of these components. Have that one. So yung sa una, sa ilalim, this is delta H of the reaction, 298. This is delta H at 500. This is the delta H associated with PB change. So let's associate delta H with O2. And this is delta H associated with PBO. Now we set up our thermodynamic loop. Again, doesn't really matter what direction we go. So sa thermodynamic loop natin, your summation ng lahat ng delta H natin will be equal to 0. Sorry for moving it so much. 0 is equal to positive delta H 298 plus delta H of PBO minus delta H of 500 minus delta H of PB minus delta H of O2. Yung hinanap natin is yung delta H of the reaction at 500. Delta H 500 is equal to delta H 298 plus delta H PBO minus delta H PB minus delta H O2. Delta H at 298 Kelvin is just yung products minus reactants natin. The delta H of formation of lead and oxygen is 0 respectively. Pareho silang 0. Products minus reactants. So natitira nila sa atin is yung PBO. Delta H of PBO is negative 52.4 kilocalories plus delta H of PBO. So delta H PBO, delta H PB, and delta H O2, these are yung associated na enthalpy changes to increase your temperature from 298 Kelvin to 500 Kelvin. So this will be the integral from 298 to 500 of PBO. So we have Cp of PBO dt minus 298 500 of Cp of PB dt minus 1/2 of 298 to 500 of Cp of O2 dt. So 1/2 siya kasi 1/2 siya dun sa reaction. And putting in the values here equals negative 52,400 plus integral of 298 to 500. Cp of PBO is 11.2 dt minus 298 to 500 of Cp of PB, which is 6.3 dt minus 1/2 of 298 to 500 of 7.0 dt. So integrating this equals negative 52,400 plus, we can actually combine all of these. 1/2 of 7 is 3.5, 3.5 plus 6.3, that is, so 298 to 500 of 11.2 minus 6.3 minus 3.5, that is equal to 9.8 dt. It's equal to negative 52,400 plus negative 9.8. Solve ko muna siya. Negative 9.8, 11.2 minus 9.8 times 202, yeah, plus 282.8. Solving this, negative 52,400 plus negative 52,400, we get negative 52,117.2 calories. So ito yung delta H reaction natin for this reaction.